Hi everyone, today we'll talk about one of my favorite problem, which is search the element in a sorted array, the rotated sorted array. This is like my favorite problem and it's going to be very interesting guys. So please watch till the end to understand the classical implementation of binary search. Classical implementation in a sense like how we apply binary search in sorted array and how we can utilize the same logic and apply in the rotated sorted array. I hope you watched the previous problem. If you don't watch, please watch that and come because we'll use a lot of terms, a lot of things from that video. So make sure to watch that before coming here. And if you don't watch also, no issues. So I will explain things here also. And without wasting much time, let's get into the problem statement. Now let's talk about the problem statement. So what the problem asks you to do is they will give an sorted array and it's rotated as well. If we don't understand what is rotated, for example, let's take 1, 2, 3, 4, 5. If I do rotation one time, the array will look 2, 3, 4, 5, 1. If I rotate again one more time, this will look like 3, 4, 5, 1, 2. So this is what I mean by rotation. If you take this particular example, the rotation point lies here. So it has been rotated this many times, which is 7. So the entire array has been rotated 7 times. So it look like this. You can see 3, 4, 5, 6, 7, 8 should come before this element. That's what the sorted array means. Now they will give you a target. You just need to return the index position of the target. So if you see in the given array, we need to return index 3, which has the target element. Now, if we think about the solution, like generally, so we can apply the linear search and we can compare with the target with every single element. If we find the element, we can simply return, which will take big O of n time, right? But we can have the better solution than this. So whenever you find search and then sorted keyword in a question, you can blindly apply the binary search for this problem. So we got a keyword search as well as the sorted. So let's apply binary search and find the answer. Now before that, like hold on a minute and just think the binary solution, like what is the binary solution will look like. Just hold on a minute, just think. Now we'll see how the classical binary search works. In classical binary search, we're going to have left right pointer as well as the middle pointer, right? So let's declare it. So left is going to be this, right is going to be this, and this value is going to be our middle value. And I will, for more better understanding, let me write the index of it. 0, 1, 2, 3, 4, 5 as well. Now what you have to do is in binary search, what you will do, you will just compare whether the middle element is equal to target. If it's equal, you just simply return it. If not, the next case what you will do is you will check the mid is greater than target or not. If it's greater, which indicate that target is going to be lies on this particular side. And if this condition pass, if mid is less than target, this indicate that it's going to be lies on this particular region. That's the property of sorted. We can utilize the property of sorted array. Let's say right now that binary search telling us to search in this particular region. The reason because the whatever element if you see left side of this mid element is going to be lesser because of its sorted property. In sorted element, all the element to the right, sorry, all the element to the left will be lesser. All the element on the right will be greater than the mid. That's what the property of sorted array, right? That's why in binary search, we just neglect this particular region. We just neglect it. We just move this pointer to this particular place. That's why. Now let's move this to this particular place and now let's recompute our mid. Left is this, right is this, and mid is going to be this particular region. Now check mid is greater than the target or not. No, it doesn't, which indicate that target is going to be lies on left region, not a right region. So what we'll do is again we just move the right pointer this particular place. Now our mid is going to be this value and we'll check if mid is equal to target or not. Yeah, it does. So we just simply return the answer. So from this, what I'm trying to tell is we find a region and we just eliminate it, right? That's what in binary search we do. We just find a region, whether it will belongs to right region or left region. If it belongs to right region, we just eliminate this entire left and we'll look into the right. And if the element lies on this region, we just eliminate the entire right region and it will just look on the left. That's what typically binary search does. Typical classical binary search does. And now how we can utilize the same thing here. Let's see how we can utilize it. And if you apply the same concept here, it won't work. The because let's take right now left is here, right is going to be here, and mid is going to be this particular place. Now for example, let's take target is going to be 12. Let's say target is going to be 12. And now according to the sorted binary search property, what we'll do is we'll check if the mid is going to be greater than the target. No, it doesn't. So what we'll do is we just move L pointer to this particular position. Am I right? That's what we will do it according to the binary search. But does it work here? It doesn't, because if you move this pointer to the right, our solution lies on this particular region. But if we move this, we'll never end up with this particular answer. So you cannot directly apply the binary search. We need to alter small thing. The alteration is nothing but finding it will lies on which particular region. Now just look into this example and you can observe something. In sorted property, what sorted property will tell us this particular element should be less than the mid one. That's what sorted property tell. If you take a sorted element 1, 2, 3, 4, 5, if you're standing at this particular position, let's say standing at this particular position, and all the element this side should be less than this, and all the element this side should be greater than it. That's what sorted property, right? And if you apply the same thing here, just check if the mid is greater than the lowest value. Does it? No, it doesn't. Which indicate that this entire portion is unsorted and this portion is automatically sorted. That's what the property of sorting is tells you. And in the rotated array, in rotated sorted array, you will find only one region is sorted, one region is unsorted. So now we conclude that this particular region is unsorted and this particular region is sorted. Now once you find the particular sorted region, you just need to check whether it lies between this particular region or not. How do we do that? It's very simple. You can write like this, whether 4 is lies whether target is lies between 4 as well as the 8. Does it lies? No guys. Why I do like this? Again, based on the sorted property, we can simply write like this, whether target is lies between this range or not. If it lies, what we have to do is we need to bring the lowest point to this particular place because it lies somewhere in this particular region. So when this case fails, we conclude that it's not here, so it might be in this particular region. So what we'll do is we just move the R pointer to this particular place. That's what simply we do. So now let's apply the concept here. Now we just move this particular place. Now let's recompute the mid. So what is our mid is going to be? This is our mid. Now tell me guys, which portion is sorted right now? Which portion is sorted? Simply check if low is less than the mid. Yeah, it does, and which indicate that this particular region is sorted and this particular region is unsorted. It's obviously true. Now after finding the sorted region, we just need to check whether the target is lies there or not. Simply 10 is less than or equal to 3 and less than or equal to 12. Does this property passes? No, it doesn't. So what we'll do is we just simply move L to this particular place. So now let's move that. Now we'll find the mid. So mid is going to be this, and again we'll check whether 16 is less than or equal to 16. Yeah, it does, which indicate this region is sorted. Now after getting the sorted region, you guys know we have to check whether it lies between this range or not. So 16 is less than or equal to 3, less than or equal to 3. Does this satisfy? No, it doesn't. So what you'll do is simply move this pointer to this particular region and recompute the mid. If you find the mid, it's going to be this. And obviously we reach the answer, so we can simply return the index position of it. I hope you guys understand this logic. Now let me write the important points. So important point is going to be, the first important point is going to be, you need to identify which region to eliminate. That's what your first goal is to be. And to identify that, you simply do this check. If mid is greater than low. If it does, which means this right side position, left position is already in a sorted region. So just check whether the target lies in this range. Check target lies here. Target lies in left region. If not, simply move the low pointer to the mid plus one. Simply. If this condition fails, what you have to do is check the target in the right region. Very simple, guys. You have to remember this thing only. And then remaining all the things are from the binary search pattern. So without wasting much time, let's write the pseudocode for this. We'll have a function as input. We are going to get nums as well as the target and the size of an array. Now what we'll do is we'll just declare low and high pointer. Low and high is going to be 0 and n minus 1. Now let's start the while loop. While low is less than or equal to high, and we'll find the mid. So mid is going to be low plus high divided by 2. And from typical binary search, what we'll do is we'll simply check if nums of mid is equal to target. If it does, we can simply return the mid value, right? If it doesn't, we need to find in which region it lies on. So the simple if case, if nums of mid is greater than the nums of low. If it does, which means the left side is already sorted. So if it's already sorted, now we need to check one more case that whether it lies on this particular region or not. For that, we can simply write if nums of low is less than or equal to target and nums of and target is less than or equal to nums of mid. If it does, if it lies in this particular region, we simply move the high pointer to mid minus 1. I is going to be mid minus 1. Simply. If not, simply what we can do is else low is going, if it does not present in this particular region, what we did is we just move low pointer to the mid plus 1. Simple. Now, what is the else case? Like what if it lies on this particular region? Same, we will check whether it lies on this particular region. If it does, we move the low pointer to this place, and if it doesn't, we just move the high pointer. So the case is going to be if nums of mid is greater than or equal to target and target is less than or equal to high. Nums of high. This one. If this is lies in this particular region, we can clearly tell that to move the low pointer. So low is going to be mid plus 1. If not, simply move high pointer. High is going to be mid minus 1. That's it. And at last, you can simply return -1 because if the target is found, we'll return here itself. If it doesn't, we'll return -1. -1. That's it. Very simple. Now, quickly, we'll code this up. Now let's declare the low and high pointer, guys. So low is going to be lies at the starting and high is going to be lies at the ending. Now let's apply the typical binary search pattern, like low is less than or equal to high, and I will find the mid. So mid is going to be low plus high divided by 2. If we found the target, if target found, we just simply return the index of it. So nums of mid is going to be target. We can simply return the mid index. If not, we have to find which region is sorted and we need to eliminate the other region. For that, what you can do is if nums of mid, if you remember carefully, sorted property, use the sorted property. Nums of mid should be greater than or equal to nums of low. If it does, which indicate left region is sorted, and you have to check whether the target is lies in this region or not. Simply if nums of low is less than or equal to target and nums of and target is less than or equal to nums of mid. If it does, simply move the high pointer. I is going to be mid minus 1. If you don't understand, let's say 1, 10, 8, 7, and then 3. If not, if this is failing, which indicate that it's not present this side, we just look into the right part of the region. For that, we can just simply move the right pointer, sorry, low pointer. And then the next case, I mean the else case. What if it lies on right region? Again, check the boundary cases. If target is greater than or equal to nums of mid, as well as the less than or equal to high value. If it does, then move the low point at this particular place. Low is going to be mid plus 1. Else, simply move the high pointer. High is going to be mid minus 1. And at last, simply return the negative 1. I hope we covered all the edge cases. Now let's run this and see. Yeah, I just passed all the test cases. Now let's submit this and see whether it's passing all or not. Yeah, it does. We just passed all the test cases. I hope you guys understand this problem. It's very easy, I guess. So I think we finished the binary search pattern and we'll move on to the next topic. And I just want some suggestion, guys. Do you want me to, I mean, after this blind 75 series, do you want me to start any particular pattern series, for example, DP? You can see in binary search, we have a lot of patterns in binary search and DP and graph and even sliding window. So do you want me to pick any one of the topic and make pattern out of it, or do you want me to do something else? Do let me know. And right now, I know we're just covering blind 75 series, which are the most important problem for interview purpose. So we don't cover a lot of patterns in this position. For example, you see this particular two patterns, but there are many patterns in binary search. Likewise, if we talk about DP, we have 1D DP, 2D DP, and then lot many patterns are there. And do let me know what we can do after this blind 75 series. And I also have some plans to make concept on OOPS kind of things. OOPS with a real world project. We'll make a real world project and explain OOPS concept in detail. So let me know your thoughts on the comments. Then until then, bye.